Hello, good morning everyone. Welcome to you all in my course, that is Periodic Table and Periodic Properties of the Element. I am Dr. Abhilekha Sharma, Associate Professor, Department of Chemistry, Noida International University. Now you will think that why we should learn this program, what are the various benefits. So the various program goals for this program, that this program will tell you about that development of periodic table as a method of organizing elements only. You will be able to understand that elements are placed on periodic table due to their similar properties. You will be able to identify that a period and a group in periodic table. Now, how elemental properties are related to position of the elements on periodic table. Then again, you the students will be able to understand that periodic table is one of the most useful tool a scientist or a chemist has. It not only relate information about the atomic structure of atoms, but it also allows the prediction of many physical properties. The reactivity and stability of different families of the elements to their structure, including alkali metals, alkaline earth metals, halogen and noble gases, etc. The characteristic properties of metal, non-metal and metalloids, and their classification of elements according to these properties. Now, what are the various program objectives of this course are: after doing this, the student will be able to correlate the properties of elements and their compounds with their electronic configuration. Second, the student will be able to establish a relationship between the behavior of different elements. Again, student will be able to classify an element, that whether it's a metal, non-metal or metalloid, based on its physical and chemical properties. He or she will be able to understand that the current periodic table was developed over a time based on many discoveries, models and revisions. So these are the objectives and the goals of this course. Hope you will enjoy it. And the course structure or the various module you will study over here, that these are the various modules. Under the module 1, you will understand periodic table and its development, periodic properties, its definition and the classification. Under module 2, you will able to understand or you will study about the effective nuclear charge, penetration of orbital, variation of sp, d and f energies of atom in the periodic table, electronic configuration, atomic and ionic sizes. Under module 3, ionization energies, electron affinity, electronegativity, covalent bond, polarizability, oxidation number, half reactions, etc. And under module 4, you will study about the metals, non-metals, metalloids and their various properties and their applications. So this is the whole content you will study under this course. We will go one by one. Hope you will enjoy this whole course. Now we'll start with the module 1, which tell you all about the periodic properties, definition, classification and periodic table development. So this is the whole structure of the latest periodic table, or you can say it is the modern periodic table. Here you can clearly see that this is the yellow colored, all these are the metals. The purple colors are the metalloid and all these are the non-metals. So this is the whole advanced version of your periodic table. But how this occurred or how this developed, is it was from the starting? No. The various scientists worked on it timely, on time, and they just developed this new one, right? So we'll start the development of how it took place. Now first one. Yes, again this is a periodic table which is showing you that what are the various uses of the elements. Now, how the development takes place, before that you need to understand that what is a periodic table actually. Periodic table is a tabular arrangement of the chemical elements organized on the basis of their atomic number. Remember, atomic number, not the atomic masses, as the earlier work was done on the basis of their atomic masses. Then again, electronic configuration and recurring chemical properties, right? So the first one in the 1817, John Devernier was there, and he gave the triad, means he just put out the 3 elements these three: lithium, sodium, potassium, then calcium, strontium and beryllium, chlorine, bromine and iodine. He just put these triads, and these were known as the John triads, and this was given in 1817. Now after the John, the Berzelius in 1828, he published his table of atomic masses containing 54 elements. Most of his value confirm with those in the modern periodic table also, right? Then in 1864, John Newlands was there. What he did, he just arranged the elements in an order of increasing atomic masses. He arranged elements in groups with 7 members, each similar to the octave of the musical scale. That's why we also told this principle as the Newland law of octaves, right? Then after the octave, Julius Mayer was there. We generally know that the Julius Mayer and the Mendeleev both worked together, but it is the work of the Mendeleev who got first published. That's why we are giving whole credit to the Mendeleev, although this is the work of a complete combined work of various scientists and development. So what the Julius Mayer did, he was working on the periodic table consisting of the 56 elements. He maintained that the properties of the element were function of their atomic masses, and he prepared a graph wherein he plotted the atomic volume of the elements against its atomic masses, right? Now in 1869, as earlier I told you that the whole credit goes to the Mendeleev, but it is not the whole sole work of the Mendeleev only. It was a consistent development of the consistent work of various scientists for the development of this modern periodic table. So in 1869, Mendeleev, he just gave his version of the periodic table, which was the first accepted version of the periodic table. He grouped elements according to their atomic masses, and as he did, he found some families had similar chemical properties, means they were showing the around similar chemical properties, and where he was not able to find the resemblance in the chemical properties, what he did, he just left some blank spaces over there to add the new elements in the and he just predicted that we are not discovered these elements yet, but they will be coming definitely in future in these spaces, and he was absolutely right at that time. So this was the whole periodic table. It was given by the Mendeleev earlier, and you can clearly see here that the blank spaces are here, here again, here and here. So why he left again the places? Because he was not able to find the similarities, so he left. And in future, in the modern periodic table, we are these places are filled with the new elements, right? So it was all about the how periodic table development was had taken place. Now the periodic properties, whenever we are keeping the elements in the order of their increasing atomic number, certain sets of properties recur periodically. So they are coming in a sequence. So these are the various periodic properties. Now what are these periodic properties? The metallic, non-metallic and metalloid properties. Number 2, the effective nuclear charges, electronic configuration, atomic and ionic radius, then ionization energies, and that is the energy required to remove an electron from the outermost electron in its gaseous state. Then electron affinities, it is the energy required to add an electron in a neutral atom in its gaseous state. Then the electronegativity, polarizability, oxidation number and half reactions. So under this module, we will study all these properties and their sequences when we are moving left to right in periodic table or up to down in a periodic table. So this is a whole you can say just summary of the various properties whenever we are moving up to down in periodic table, and left to right, how these non-metallic character is moving like this way, more negative electron affinity. So why this is happening and how this is happening, we'll study all this in course, right? Now again, this is the modern periodic table. Here this is a picture of a modern periodic table. So if you are moving across like way, then these are various periods, right? Now if you are moving up to down, then these are various group 1A, 2A, 3A, then 13, 14, 16, 17. All these are the groups. Then if in these group, if you are talking about the 1A, then these are the alkali metals. If you are talking about 2A, then these are the alkali earth metals. 17 group is the halogen group, and then 18 is the noble gas group. We are having all these types of various groups in the whole periodic table, right? Now, if we want to classify further the elements, so elements can be divided into groups or the families. Each column of the periodic table contains one element family. Just as human family members, often they have the similar looks, traits, choices, differences. In the same way, in a periodic table, we are also having the similar properties, chemical properties, which are placed in the same group or same family. Then hydrogen is usually considered separately. So the first element begins with the lithium and sodium in the first column, right? Then we will start these families one by one. The most important, the noble gases. If you will look at here, these are the noble gases: helium, neon, argon, krypton, and etc. So neon and the element below it in group 18 have 8 electrons in their outer energy levels, means they are having complete octet. Complete octet means they are least in their energy. They won't react with anyone. That's why, as their energy levels are stable, they do not combine easily with other elements. That's why the name, as it indicates, noble. They are noble gases, right? Now the halogens. The elements in the group 17 are called the halogens, and fluorine is the most reactive halogen in this family because its outer energy level is the closest to the nucleus. Now the first property, that is the effective nuclear charge. The definition of this effective nuclear charge, that in each electron in a multi-electron atom experiences both the attraction towards the nucleus and it is also feeling the repulsion, which is due to the presence of other electrons in the atom. So this repulsion, electron to electron repulsion, causes the electron to have a net reduction or reduced attraction to the nucleus, means the outer electron is shielded by the inner nucleus, means it is shielded from the nucleus via the inner electrons. So the total amount of the attraction that an electron feels for the nucleus is called the effective nuclear charge of the electron, right? Now, what is electron shielding? Here I explained you about the effective electron shielding. So what is the electron shielding? Electron shielding is basically the protection, or you can say the oppose of the inner electron to the outer electron. Suppose if you are checking the shielding of this outermost electron, it is having all these inner electron which will shield this electron and also these electrons also. So the outermost electron will be having less force of attraction due to presence of these inner electrons, right? So the total force of attraction which this outermost electron is feeling is known as effective nuclear charge. Now, and you can say the inner electrons are shielding the outermost electron. Now, if you want to calculate the effective nuclear charge, how you will do it? The effective nuclear charge calculation is done by the ZEFF, means the effective nuclear charge equal to Z minus S, where Z stands for the nuclear charge, or you can say it is equal to the atomic number, and S stands for the shielding effect of the other electrons, right? Now, how you will do the calculation of this shielding, right, or effective nuclear charge? For this we are having the Slater rule. This is the Slater rule. So if you want to calculate the effective nuclear charge, first you need to write down the electronic configuration of the given element. Now you will be do the grouping of the other remaining electron, whether they belong to S orbital, P orbital, D orbital or the F orbital. The outermost shell will be known as the nth shell. Then After that it is the n-1, n-2 and n-3. If the electrons which are present on the same shell will be multiplied by 0.35, it is for the s and p orbital, and below that it will be multiplied by 0.85, and after n-1 it will be multiplied by 1.0 only, right? If your electron belongs to the s or p block orbital, right? If your electron belong to d or f orbital, we are having quite little bit different calculations. You can look at here. If your electron belongs to the s or p orbital, then if your electron is in this shell, means this is the nth shell, then the total number of electron minus 1 multiplied by 0.35 plus the number of electron in n minus shell multiplied by 0.85, then electron in n-1, n-2 or so on. The total number will be multiplied by 1.0. But suppose your electron belongs to d or f orbital, then how you will do its calculation or shielding effect? How you will calculate the number of electron in the nth shell? It will be multiplied by 0.35. Then n-1, n-2, n-3 or so on, you all will multiply it by the 1.0, the number of electron multiplied by 1.0. So here I am giving you example. If suppose you want to do the calculation of effective nuclear charge, or you can say shielding, then how you will do? 2p electron in the fluorine. So this is the first, you need to write down the electronic configuration for the fluorine. Fluorine is having the atomic number 9. So it is 1s2, 2s2 and 2p 5, right? If suppose you want to do the calculation of this electron in the p orbital, 2p orbital, then the total number of electron in the second shell, it is 5 plus 2, 7, and one electron is your electron of your interest, so it will be 7 minus 1. As I told you that you need to deduct one electron from the nth shell, right? So it is 2 electron in the 1s orbital and 6 electron in the second shell, right? So the shielding constant, as I showed you in the earlier PPT, the nth shell electron will be multiplied by 0.35 if your electron of interest belong to the either s or the p orbital. Then it is the total 6, 7 minus 1, 6, 6 multiplied by 0.35 plus 0.85 multiplied by number of electron in n minus 1 shell. So 1s2 is the n minus 1 shell. So 2 into number of electron is the 2. The 2 into 0.85. If we'll do this, we will add this calculation. It will come 3.8. So effective nuclear charge for the fluorine and the 2p electron in the fluorine will be 9. 9 is the atomic number of the fluorine minus 3.8, that is the shielding constant. So 5.2 is the effective nuclear charge that is felt by this 2p electron, right? Now the another example, if you want to calculate the 4s electron in calcium. So this is the calcium's electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, and you want to calculate the shielding constant for this 4s electron. Again, your electron of interest belongs to the s or p orbital. Here it is in s orbital. So number of electron of interest, so minus 1. So what will be remaining here? It will be 2 minus 1, 1. Then it is the n minus 1 shell, and this is the n minus 2 shell, and this is the n minus 3 shell. So for this it will be multiplied by 1 multiplied by 0.35 plus 8 multiplied by 0.85, then 8 plus 2, 10. 10 multiplied by 1.0. So this whole calculations comes out at 17.15. So Z effective will be atomic number 20 minus 17.38, which is this one, right? So 2.85 is the effective nuclear charge for calcium for the 4s electron in the calcium, right? So here in two examples you can easily understand that as we go farther from the nucleus, the effective nuclear charge decreases, right? Now again one more example is there. If it's nickel, then the nickel and the, now you are doing the calculation for the 3d electron, right? So 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 8, 4s2 is the electronic configuration of the nickel. So this is the nth shell. then this is n minus 1. So total, how many will be there? 8 plus 2 plus 8, right? So it is 18 multiplied by 1, and 8 minus 1, that is 7 multiplied by 0.35. So it is coming 20.45. So this is the atomic number minus shielding constant, that is 7.55. 7.55 is the effective nuclear charge for the 3D electron. Now for the same element you want to do the shielding constant calculation or the effective nuclear charge calculation for the 4s. Now the calculation will be slightly different with these numbers only. So the total number of electron here in 4s, it is 2 electrons, so remaining will be 1, 2 minus 1, 1 into 0.35, 16 are there in the n minus 1 shell, right? So this is 8 plus 2 10 and 6 16. 16 multiplied by 0.85, that is the calculation for n minus 1, and the 10, these are the 10 electron multiplied by the 1.0, so the result is 23.95. So it's the effective nuclear charge for the 4s electron in nickel will be 28 minus 23.95, that is the 4.05. So this is the way how you can use the Slater rule for the calculation of the effective nuclear charge. Hope you have enjoyed all about the how the periodic table development took place, and then the various periodic properties in which we just studied about the effective nuclear charge and the calculation with the Slater rule and the various types of families, halogens, then noble gases, and the groups and period in the periodic table. So till next module, bye bye. Take care of yourself. Do study at your home. Bye. Thank you.